Have you ever wondered what it would be like to travel near a black hole? It's a mind-bending concept, and one of the strangest things that happens involves time itself. Spoiler alert, it gets weird. Thanks to Einstein's theory of general relativity, we know that gravity isn't just a force pulling things down. It's a curvature of space-time caused by massive objects. The more massive an object, the more it warps the fabric of space-time around it. Now, imagine an object with so much mass packed into such a tiny space that its gravitational pull is inescapable, even for light. That's a black hole. It creates an incredibly deep gravity, distorting spacetime to an extreme degree. This distortion has a profound effect on time, a phenomenon known as gravitational time dilation. So, what does this actually mean for you? Let's do a thought experiment. Imagine you're on a spaceship, safely orbiting a black hole, while your friend stays on Earth. For every single hour that passes for you, years, decades, or even centuries could pass for your friend. From your perspective, everything feels completely normal. Your heart beats at its usual pace, your clock ticks once per second, and you can watch a movie in 2 hours. But if you were to look back at Earth through a hypothetical super telescope, you'd see history flying by at lightning speed. Why does this happen? The intense gravity of the black hole is literally slowing down the flow of time for you relative to an observer in a weaker gravitational field, like your friend on Earth. The closer you get to the black hole-less event, arising the point of no return, more extreme this effect becomes. Let's take it a step further. If you were to hover just outside the event horizon, time for you would slow down almost to a stop compared to the outside universe. You might spend a few minutes there, but when you return to Earth, you could find that millions or even billions of years have passed. Everyone you ever knew would be long gone, and humanity itself might be unrecognizable, or might not even exist anymore. You would have effectively traveled into the distant future. This isn't just science fiction. It's a real, tested prediction of Einstein's theory. GPS satellites in orbit around Earth have to account for a tiny amount of time dilation, because they are in a slightly weaker gravitational field than we are on the surface. Their clocks run just a fraction of a second faster. It's a minuscule difference, but if engineers didn't correct for it, your GPS would become inaccurate by several miles every single day. So, black holes are the universe's ultimate time machines, but they only travel one way, into the future. Once you crossed that event horizon, there's no coming back. According to our current understanding of physics, the intense gravity would stretch you into a long, thin strand in a process gruesomely nicknamed spaghettification, before you ultimately reach the singularity at the center, a point of infinite density where our laws of physics break down. What happens inside a black hole? is one of the greatest mysteries in science. But what happens to time asterisk? Near asterisk, a black hole is one of the most fascinating and confirmed predictions of modern physics. It shows us just how strange and wonderful our universe truly is. I hope this gave you a new perspective on time and space. If you enjoyed this journey to the edge of a black hole, don't forget to hit that like button and subscribe for more explorations into the cosmos. Thanks for watching.